whenever you're ready.
Good afternoon, ladies and gentlemen. My name is Bo Labar, and I'll be giving you a quick overview of our design project of solids, liquid, and gases. First off, let's get to the team. We have Jamie Salo starting off with marketing. Then we'll have Trevor coming with the instruction manual. Then we'll have Brendan Capello over here with the methods, and I'll be following up with experimental analysis. And credit goes out to Trevor for this awesome flyer. So we'll give it off to Jamie for marketing.
Thank you very much, Bo. Again, my name is Jamie Salo. I'm going to be talking to you today about the marketing part of our presentation. First off, I'm going to touch on the acceptability. The functional performance of our presentation showed us that we achieved very high retention rates based off of our matter worksheets. Also, for the operating costs, to conduct this presentation again, you just need to purchase more otter pops and dry ice, as well as a negligible amount of electricity required to run the digital projector and the computer for the amount of presentation. A little bit about the ease of use characteristics. It requires very minimal supplies and has a very low production cost, as well as it's easily understandable by any instructor grades K through 12. Next, I'm going to talk to you about the adaptability. A little bit about the adaptability of our presentation. We used the VARC learning techniques: visual, auditorial, read, write, and kinesthetic. A little bit of the modifications that we came up with to make our presentation suitable to other grade levels were the ideas of introducing molecules and the classification of matter known as plasma that would be applicable to middle school and high school students. Also, we could show students the relationships between phase changes, energy, and atomic properties within various elements. Also, you can adjust the interactive experiments and the matter handouts to better suit students' grade levels. A little bit about the curriculum and how our presentation tied in with that. In grades K through 2, students learned that matter exists as solids and liquids. In grades 3 through 5, students learned that heating and cooling can change common materials from one state of matter to the next. In middle school grades 6 through 8, students learned that particles are arranged differently in solids, liquids, and gases of the same substance. And in high school, students learned that physical properties in solids, liquids, and gases differ based on molecular arrangements and motions. Next, I'm going to hand it off to Trevor, and he's going to talk about the instruction manual.
Thank you, Jamie. Good afternoon, everybody. My name is Trevor, and I'm going to go over the instruction manual today. There are 3 key requirements for an instructor to teach this class. By show of hands, how many people here would be able to explain the differences between solid, liquids, and gases? Okay, good. So most of you would qualify to teach this lesson. Basically, the instructor needs to know the states of matter. They need to go explain that matter is the stuff around us. They need to explain the differences between solids, liquids, and gases. Also, the budget for this is pretty cheap, $20. You can see in table 1 here the total cost for our experiment. The main cost comes from the dry ice, $12. Also, the styrofoam cooler, $3. That can be neglected if they have their own cooler, making it a total of $17. Also, the time required for this took about 90 minutes, which includes setup time and cleanup time. You can see here for our lesson timeline, we start off with a presentation setup. This includes setting up the projector, getting everything set up for the kids, having examples ready on the table. Next, you go into your lecture. Well, this is where you explain matter. You'll explain solids, you'll explain liquids, and then you'll
I'm going to be passing it over to Bo for our experimental analysis.
Thank you, Brendan. I'll be talking about experimental analysis, which includes the survey. What we did for our survey was a little different than the normal survey. Then we have the test results from that and the documentation behind everything. So for our survey, we thought of going with a worksheet instead. For the age group was a big deal, so we went with the kindergartens. We wanted them to focus on the picture section where they had to match the word with the picture, so it really got them used to seeing each form of the phase of matter. And if they felt brave enough, they could go up to the fill in the blank section. And as you can see, there's another worksheet that we had the first graders work on, and they dealt with everyday items such as shampoo, ice cubes, oil, and they just had to classify it as a solid, liquid, and a gas. For our test results, we got back a 95% average, which was fairly, it was a good reflection on what our presentation worked on. And for their reward of hard work, we gave them Otter Pops, which also helped them understand it started off as a solid and then melted, turned to a liquid. Some observations that we saw, we actually hit them with like 3rd grade curriculum, so it showed that they actually picked up some material that was far beyond their grade level, and it really worked out. The overall analysis we saw from the teacher, she really came up to us and said that it was a really good presentation, and ended up working with what they were learning throughout their kindergarten and 1st grade sessions. Some errors that we dealt with, we really didn't have a classroom layout, so we went in there not knowing where we would set up the projector, so it just took a little more time. And other than that, another one was the questions that they had. Some really didn't make too much sense, so we couldn't discourage them by telling them that they were wrong, but we just had to rephrase it in their own words. Other than that, that was all good. And I'll pass it off to Trevor for the conclusion.
Thank you, Bo. So to wrap things up, in the beginning we talked about marketing, how our lesson plan could be adapted to different grade levels. Then I talked about the instruction manual. Basically the lesson cost $20 and it was 90 minutes of time. Then Brendan went over the methods, which described what we wanted these kids to come out of. We wanted them to be able to identify solid, liquids, and gases. And then Bo went over the experimental analysis, which showed a very high retention rate, and also that these kids had a lot of fun doing it. This is a page for our references. And that concludes our presentation. I'll open the floor for questions.
Yes, I have a question for Bo. Just out of curiosity, what kinds of questions did the students ask after the presentation?
There were quite a few. There was some of the kids, they were asking about how, like, what happened between ice and water, like how it actually broke down. And we told them that just heat adds that up. Another question, there were some like, is gasoline a gas? They were just confused on some things, but overall we straightened it out, and they did. Thank you.
I have a question for Trevor. Where did you get all your materials, like the dry ice?
That's a good question. Here in Reno, we have a company called Crystal Ice and Oil, where you can buy 10-pound bags of dry ice, which is a good size for classroom experiments. In cities that don't have this Crystal Ice and Oil, you can get this at local grocery stores like a Safeway or Friday's. Thank you for your question.
I have a question for Jamie. In your section, you mentioned using bark learning techniques. Can you give a brief example of how you use them?
Yes. In our presentation, we demonstrated all 4 techniques, and we did so by, when we gave our presentation, the students got to see the visual and auditorial sides of our presentation, getting to see all the pictures and read the presentation and then hear us talk about it. And then by conducting our interactive experiments, they got their hands-on kinesthetic learning, and then after our presentation was done, they got their read and write by conducting or performing the remote handles. Thank you for your question.
I have a question for Brendan. Do you consider, since you guys were teaching kindergarten and 1st graders, that maybe the states of matter, was it appropriate, do you think, or was it a little bit too much for them to take?
At the start of our presentation, we asked them if they could identify like the 3 states of matter, and we just received blank stares. So I kind of panicked a little bit, but as we got into each of the different states of matter, we gave them examples and would ask them to give us examples. And once they started like understanding the different types of examples, they were able to grasp the differences, like the solids, liquids, and gases. Thank you for your question.
Are there any more questions? Okay, thank you. This concludes our presentation.